Okay, in this section, last section of Chapter 2, we are finally going to be getting to some applications of these functions, where right, until now, these functions have just been mathematical expressions, and they don't necessarily represent anything. That's going to change in this section, because we're actually going to be creating functions to represent something tangible, like a distance or an area or a volume or a cost of something. So this is all about applications. And there's no real single formula we're going to be using. It just completely depends on the example, and so we're just going to jump right into it. We are going to assume that you know the basic stuff like the area of a circle, the perimeter of a rectangle, and so on. If you're not familiar, if you haven't memorized all these formulas, don't worry about it. I will give it to you on a quiz or on a test. But just want to get the basic idea of what we're doing. So in this first example, I want you to write the distance between a fixed point, 1, 3, and a point on the line y equals 2x plus 4 as a function of x. Okay, so we know what the distance formula is. Okay, so maybe we can just draw a picture first. Here's our line, and here's the point 1, 3, and here's our point on the line x, y. Okay, and we know that the distance would be the square root of x minus 1 squared plus y minus 3 squared. Okay, now normally that would be it, but we want this to be a function of x. We don't want this y there, so we want everything in terms of x. Well, how can we eliminate the y? Well, we know that this point is on the line y equals 2x plus 4. So we can simply replace y with 2x plus 4. Okay. So now this becomes the square root of x minus 1 squared plus 2x plus 4 minus 3 quantity squared. Okay. And then we can simplify this. This is 2x plus 4 minus 3, so that would be 2x plus 1. Okay, and so that's the distance. That's the distance formula. Now, so now this way you can plug any value of x in there, and find out what the distance is. Okay, so if you wanted to plug in, let's say, just x equals 3, right? You plug that in, and the distance would be 3 minus 1 squared plus 2 times 3 plus 1 squared, and that would be 2 squared plus 7 squared, which I think is 4 plus 49. So this would be the square root of 53. And you can just plug in any value. Notice that we don't have to simplify. We don't have to simplify this. Okay. Okay, for the next couple of examples, you have to remember what is the area of a rectangle and the area of a triangle. Let's do the triangle first. So here we are getting finding this shaded region. This is a triangle. It's completely determined by this point here. And we should probably call this, give the x coordinate there, sx. Now, notice that this is indeed, the area is a function of x, because we're going to get a different area for every value of x, because we get a different x, we get a new point, and we get a new triangle. Well, remember the area of the triangle is 1/2 base times the height. Okay, the height, if you will, is going to be this distance, which will be the y-coordinate of this point, which is x squared, and then the base is this distance x. Okay, so the base, so this is going to be 1/2 the base, which we said is x, and the height is x squared. So we get that the area is going to be 1/2 x cubed. And no, this is not the typical area formula for the area of a triangle, but it's the area of this triangle, which depends on x. Okay. Similarly, let's see if we can find the area of this rectangle. We know that the general formula of the area of a rectangle is length times width. Okay. What will be the length? Well, that's going to be the distance from here to here. So it's not x. X is the distance from here to here. But the length would be what? Would be 2x, right? Okay. And then what would be the height of this, or the width of this rectangle? Well, that's going to be the y-coordinate of whatever this point is. And what is y? Well, because this point is on the circle x squared plus y squared, we can solve for y. And we get y squared is 1 minus x squared. And so y would be plus or minus the square root of 1 minus x squared. But we don't use the minus sign, right? Because clearly this distance is a positive number, right? So we want to take we want the positive y value. So this is just going to be the positive square root of 1 minus x squared. Okay. So that's the area of that shaded region, that shaded rectangle.